Hey guys, this video walks you through questions 19 through 24 on your study guide, so it is kind of lengthy here. All right, so first up, we want to find the equivalent resistance of the circuit, and we do have a parallel circuit here. So to find your equivalent resistance, you're using the inverse equation. So it would be 10 to the negative 1, or the inverse of 10, plus the inverse of 20, plus the inverse of 30, plus the inverse of 40, and then you're going to take the inverse of all of that added up, and that will give you your equivalent resistance for the parallel circuit. So when you type that in your calculator, you should get an answer of around 4.8. Right? So your equivalent resistance for the circuit is 4.8 ohms. Right? Easy enough. So next up, we're going to fill in this chart. So you can go ahead and fill in a resistance since I didn't do that for you. So 10, 20, 30, 40, and then your equivalent resistance you just found a 4.8, and all your resistances are in ohms, your current is in amps, and your voltage is in volts. And it also gives you your total voltage for your circuit of 24 volts in the diagram. So this is a parallel circuit, so your voltage remains the same through each branch. So each of these resistors are going to get 24 volts. So you can go ahead and fill that in. Now to solve for your current overall, your current varies for each branch. So you are going to use Ohm's law to solve for your current. So it's voltage equals current times resistance. So you're essentially dividing your voltage by your resistance to get your current. And we're going to do this for each resistor and for our total. So for our first resistor, when you divide 24 by 10, you're going to get 2.4. Then for the second one, 24 divided by 20 is 1.2. Then 24 divided by 30 is 0.8. And then 24 divided by 40 is 0.6, and then 24 divided by 4.8 is going to give you 5. So that's everything for our chart. Next up in 21, it wants you to draw this as a series circuit with the same resistors. Now, if I ask you to do this on the test, make sure you are using proper symbols and you are drawing it neatly and doing everything you're supposed to. All right, so you would have your battery cell is the 2 lines, and then you're going to have this is kind of hard to do on my iPad, but you're essentially going to draw each one, and hopefully your squigglies look a little better than mine for your resistors. And you're going to have R1, R2, R3, R4. I know that's hard to read, but make sure you do label them on your test, right? So now for 22, we're going to determine the new equivalent resistance of the circuit in series. So series is the easy one. You're just adding them up. So it's just 10 plus 20 plus 30 plus 40, and when you add that up, you get 100 ohms. Your new equivalent resistance when it's in series is 100. Next up for 24, we want to fill in this chart, so we'll go ahead and fill in our resistances. They're the same as before for each resistor, and our new equivalent we found was 100, and all of this again is in ohms, currents in amps, and voltage is in volts. And your overall voltage does remain the same. However, our voltage is going to be different on each resistor because in a series circuit, your current stays the same. So we need to go ahead and find our overall current for our circuit. So you are going to use Ohm's law. You're going to plug in your 24 volts and solve for I, and then your 100 ohms of resistance. So you're going to get a current of 0.24. Now that's the same at each resistor in a series circuit. So you're going to have 0.24 amps of current going through each. All right, and now we want to solve for our voltage. So again, it's going to be your Ohm's law, voltage equals current times resistance. So you are just multiplying these two columns. When you multiply 10 times 24, you're getting 2.4 volts. 20 times 0.24 is going to be 4.8 volts. And then 30 times 0.24 is 7.2. And 40 times 0.24 is 9.6. And now you've solved everything. Hopefully you were able to follow along. If you have any questions, please ask me in class.